Database Health and Maintenance Speech Script Introduction. Good morning, students. I'm Mr. Bell from Ctech, CaesarBrotherTech.com, and I'll be your guide through this course. Today, we're diving deep into Lesson 9, Maintaining Database Health. Think of a database as a living organism. Just like how we need regular checkups to stay healthy, our Oracle databases require continuous monitoring, preventive maintenance, and proactive care to function at their best. In today's session, we'll explore how to keep your database in top shape, identify potential issues before they become critical problems, and maintain optimal performance levels. Core components of database health. Let's break down the four main areas we need to monitor for database health. 1. Memory management health. Memory is the lifeblood of your database system. The key components we monitor include System Global Area, SGA. This shared memory structure includes buffer cache, stores recently used data blocks, shared pool, holds SQL statements and execution plans, large pool, handles large memory allocations, Java pool, manages Java code in the database program global area, PGA. This is memory allocated for each user session. To assess memory health, we look at indicators such as buffer cache hit ratio. Are we finding data in memory instead of disk? Library cache hit ratio. Are we reusing SQL execution plans? Memory sorting ratios. Are sorts happening in memory rather than on disk? PGA usage statistics. Are we allocating memory efficiently? 2. Storage health. Storage is the foundation of your database. We need to monitor table spaces, logical storage units, data files, physical files that store your data, redo logs, record all changes to the database control files, contain database structure information, archive logs, saved, redo logs for recovery, temporary segments, for operations like sorting, undo segments, for transaction rollbacks, and read consistency. Key indicators of storage health include space usage and fragmentation. Is space being used efficiently? Segment growth patterns. Are tables growing as expected? Extent allocation efficiency. Is space being allocated optimally? Table space, free space. Do we have enough room for growth? 3. Process health. Processes are the workers of your database system. Background processes handle system tasks automatically. Server processes execute SQL on behalf of users. User processes connect applications to the database, process resource usage, CPU and memory consumption. 4. I/O subsystem health. I/O operations often become bottlenecks, so we must monitor disk I/O, reading and writing data to storage network I/O, data transfer between clients and server backup I/O, backup and recovery operations, archive log I/O, writing and managing archived logs, monitoring and maintenance tools. Now, let's look at the tools Oracle provides to keep our databases healthy. 1. Dynamic performance views. These views give us real-time information about the database. SQL copy. Key views for monitoring SAT, system statistics, system event, wait events, session information, SCAStat, SGA statistics, GAStat, PGA statistics, data file information, process information. These views are like a dashboard showing what's happening right now in your database. 2. Data dictionary views. These DBA views provide information about database structures. SQL copy, essential DBA views, DBA table spaces, DBA data files, DBA segments, DBA free space, DBA hist active, SES history. Think of these as your database's medical records. They tell you about its configuration and components. 3. Automatic Workload Repository, AWR. AWR is like your database's fitness tracker. It takes regular performance snapshots, analyzes trends over time, stores historical performance data, lets you compare against established baselines. 4. ADDM, Automatic Database Diagnostic Monitor. ADDM is your database's personal doctor, providing automated performance diagnostics, root cause analysis of issues, specific performance recommendations, time-based analysis of problems, proactive health maintenance. Let's look at some practical ways to maintain database health. 1. Space management. Here's a query to monitor table space usage. SQL copy. Monitor table space usage. Select table space name, round used, space 100, table space size 2, as used percentage, round to table space size 8192, 1024, 1024, 2. As size MB from DB8 are tablespace usage metrics. This query shows you which tablespaces might be running out of space before they become critical. 2. Performance optimization. Here's how we can identify system bottlenecks. SQL copy. Monitor system wait events. Select event. Total, weights, round, time, weighted, micro, 1,000, 2. As time, weighted seconds. Round, time, weighted, micro, total, weights, 1,002 as AVG weight Ms from V system event, where weight class, idle, order by time, weighted, micro, desk. This tells us where the database is spending its time waiting, often pointing to performance bottlenecks. Health monitoring strategy. A comprehensive health monitoring strategy involves 3 time frames. 1. Short-term monitoring, daily, check session activity, who's connected and what are they doing. Monitor resource usage. Is CPU, memory, or I/O spiking? Review space utilization. Is anything growing unexpectedly? Scan error logs. Are there any warnings or errors? 2. Medium-term analysis. Weekly, analyze performance trends. Are things getting slower? Study growth patterns. How fast are our tables growing? Identify resource bottlenecks. What's consistently slow? Plan for capacity needs. Will we need more resources soon? 3. Long-term planning. Monthly, quarterly. Assess infrastructure requirements. Do we need hardware upgrades? Plan for software upgrades. When should we upgrade Oracle? Test disaster recovery. Can we recover if needed? Optimize overall performance. How can we make things even better? Understanding health metrics. One of the most valuable analyses you can perform is looking at weight events. SQL copy. Weight events analysis. Select weight class event total, weights, round, time weighted, micro, 1,000, 2 as time weighted seconds from system event, where weight class, idle, and total weights, 0 order by time weighted micro, desk. This query reveals what's causing your database to wait, which often points directly to performance issues. Importance of database health maintenance. Let me emphasize why all this matters. 1. Proactive problem prevention. We can identify issues before users notice them. We can prevent system outages that impact the business. We can maintain consistent performance, keeping users happy. 2. Resource optimization. We ensure efficient use of expensive hardware resources. We can plan capacity needs cost effectively. We provide a better user experience through reliable performance. 3. Business continuity. The business can rely on consistent database operation. Performance becomes predictable, not sporadic. Downtime is minimized, keeping operations running smoothly. Conclusion. Remember, students' database health isn't something you check once and forget. It's an ongoing process that requires vigilance, understanding, and proactive care. The skills we've discussed today will help you become excellent database administrators who can prevent problems rather than just reacting to them. In our next session, we'll dive deeper into performance tuning techniques. Until then, I encourage you to practice these monitoring queries on our test database and see what insights you can discover. Are there any questions about what we've covered today? See you on the next lesson.